Okay, so let's go through some of these other objects. First of all, we have the select object. The select object here in the Learn New Objects by Example and Play patch, this is a functional patch so we can see it work. All right, select is similar to route. It looks at incoming messages. If they match, it sends a bang out the corresponding outlet. If nothing matches, passes the input out the right outlet. Okay, so let's see that work. So 1, this select is not looking for a 1, so as expected, it passes that 1 out the right outlet. The 1 didn't come out the right outlet of this one because select is actually looking for this in the first position. So we should see this button flash when the bang comes out of the first outlet, and indeed we do. So this select is finding the number it's looking for and reporting that with a bang. This select is not finding the number it's looking for, and so sending it out this right reject outlet. Try a 2. Okay, so this select is looking for a 2, bangs the second outlet. This select is also looking for a 2, bangs the second outlet. So a 2 triggers both of these selects. 3, it's a reject on the first select, but actually triggers the third outlet because the third argument, the third typed in argument of select here is a 3. Now neither one of these are looking for a 4, so we should see the 4 fall out the right outlet of both. And indeed we do. This one's looking for a 5 in the first position, so we should see a 5 in the reject outlet of this select, but we should see this left button flash, and indeed we do. So it's a very simple, straightforward object. The results are very predictable. The 6 is going to be rejected by both, so we'll see 6 come out of the right outlet of both of them. Great. So how do we use this? What is this for? Well, it's for anything we can think of. I mean, that's sort of the beautiful part of it. It's a simple tool that we can apply in an endless number of ways. So we'll grab one, copy it, and move over to the sandbox and see what we can do with this in the sandbox. So let's take a random, our random 5, which is giving us random numbers between 0 and 4, and we'll have a select that looks for all of those, 0, 1, 2, 3, 4. So now, I'll put an integer number box in here so we can see what's going on. Put some buttons along the bottom. Command D is your duplicate button if you want. D, D, D. And we'll use a button to fire off this random. So I click it, it generates the random number 1. The second outlet is looking for a 1, so we got to bang out that second outlet. Okay. Interesting, potentially useful. Let's see. I'm going to try to make this object so the numbers line up better with the outlets, but I can't really do it, unfortunately. So, all right, I'll leave it as is. I just know that I can put in some comments, and maybe that's the way to do it. 0, 1, 2, 3, 4. And just line up these comments with the wires. Oh, yeah, that's very useful. And again, I'm putting that comment in just for myself, just to help me understand what each of these outlets is doing. All right, random generates a 2, and the 2 outlet bangs. And if I want to see it again, as we saw in the last review tutorial, I can actually bang this number box to see a repeat. All right, so what could we possibly use this for? Well, let's say that we mostly want to hear a hi-hat sound. There's a closed hat, sound number 4, and occasionally we want to hear a kick drum. So it's sound 4 and sound 1. So why don't I say, if my random generates a 0, 1, 2, or 3, it will play the hi-hat, which is sound number 4. So I'll have 0, 1, 2, and 3 all trigger the 4th sound by sending this message 4 into our playlist. But only if random generates a 4 will it play the kick drum. So that means 80% of the time we're going to hear a hi-hat, 20% of the time we're going to hear a kick drum. Let's see if it works. that seems to be working. And then if we wanted this to play on its own, of course, we could use the structure, the route done structure, without the route 8 in there. Route whenever a sound file finishes, whenever some message comes out of here that begins with the word done, give me a new sound. And now let's see it work. Right, it's pretty easy to quickly create something interesting just by applying these objects in different ways. And if we wanted to modify this a little bit, let's say there's some other sound that we like. Let's do cowbell. Always need some cowbell. What number is cowbell? That's sound number 6, I believe. So we'll add 6 as an option here. So 60% of the time, we're going to hear a hi-hat. 20% of the time, we're going to hear a cowbell. 20% of the time, we're going to hear a kick drum. And of course, remember our G-gate object, which lets us turn things off, break this feedback loop when we want to stop hearing it, and let it go. Okay, so, we're using select. Now, here's the thing. Could we take this, what we've got here, and optimize it somehow? Because the rightmost outlet of select is the reject outlet. And most of the time, we're playing a hi-hat sound. So I could just take this, because it's kind of a mess. It's kind of a mess of patch chords, and just rethink this a little bit. I can say select 0 and 1, because we're only looking for 2 special sounds. And 0 will give us the hi-hat, which was 6. 1 will give us 1. And remember, these are outputting bang, so I have to put the number here in a message box, because I can't just send a bang to this. This won't understand it. It needs a number to know what sound to play. And then everything else plays the hi-hat click. Now that's a much cleaner arrangement, and here's a way to make it even cleaner. Put another integer number box here. Connect these to the integer number box, and then pass the output of the integer number box into my playlist, so there's only one patch cable going up here. And I'm going to get exactly the same results as I got last time, but from a much cleaner, easier to read structure. I gotta close my G-gate. All right, and it's not a particularly good groove going on, but we're seeing the functionality of the objects here, which is the important part. And you can imagine ways in which you would potentially use this in a creative way, but right now we're just doing a mechanical exploration of the objects. We're just seeing what they do. So let's see if we can find some other uses of select. I'm just going to delete that and say, all right, I have a random 5. It's giving me 5 random values, and I'll just put a select 0. Whenever random 5 gives me a 0, I want something to happen. Well, how about when I get a 0, I'm going to play a sound between 1 and 17. I need to add the +1 because remember, random gives me a range of 17 values starting with 0. So a random 17 will output a random number between 0 and 16. If I want a number between 1 and 17, I've got to add 1 to it. So if random gives me a 0, play any one of these sounds randomly. Otherwise, play sound 1, 2, 3, or 4. Let's see what happens here. Again, close my G-gate. Sound number 2 is a really long one, so we can make it shorter if we want it there. Right, so every time this random delivers a 0, select sees the 0, bangs the random 17, and gives us a sound chosen from all of the sounds. Otherwise, we get sound 1, 2, 3, or 4. And you can keep going with this. Again, this is the purpose of the sandbox. You just keep working these objects in different combinations until you really grasp them. So let's move on from this. I'll take this little structure out, save it for later over here. If this is your patch, add a comment about what it's doing, and go back in and take a look at the next object. All right, so the next object is counter. And again, we have an interactive patch here that helps us understand what counter does. Counter counts. It counts numbers and bangs. And numbers typed in set a minimum and maximum count. All right, so this should go 1, 2, 3, 4, 5, and indeed it does. And it should loop around 1, 2, 3, 4, 5. And it shouldn't care what it receives. It counts a 3 as readily as it counts a 2, as readily as it counts a bang. So really, in a way, it destroys whatever information is coming into it. You send a 2 into a counter, it ignores the fact that it's a 2 and just says, I received one thing. But the information coming out of counter is particularly useful because it's a sequence. Random and earn do not generate a sequence. They are random number generators. They specifically generate a non-sequence. But counter does generate a sequence. And we see counter's got some other features here. Like, for instance, it can count up. It can count down. Or it can count in a palindrome. It counts up to the top, up to 20, then back down to 9, then back up to 20. 20, then back down to 10, back down to 9, back up to 20, etc. It's a zigzag. The third inlet, oh, that's interesting. The third inlet we haven't talked about, but the fourth inlet resets the counter to some starting number. So if I reset the counter to 14, then when I click this, the next number will be 50. Oops, it's counting down. I'm going to count it up. Reset the counter to 14. When I hit the button, the next count will be 15, 16. If I set the counter to 16 and set it into countdown mode, the next number will be 15, because it's at 16. Now it's going to count to 15, 14, 13, 12, 11. And then, of course, we can change the count maximum. So if we want it to count all the way up to 50, put it in count up mode, it's at 11. It's going to count all the way up to 50 before it wraps around to 9. For 950, 9, right? Counter 9, and this 20 has been replaced by that 50, so it's now actually a counter 950. And that's why I put the integer number box here, by the way, so you can see if this value has been changed. There's no need to do it here because you immediately see. If I reset the counter to 15, I get that immediate feedback here. But if I reset the count maximum to 20, I don't know that unless I see it in a number box here. So that's why this example patch is built the way it is. So again, we take this, copy it, and we sandbox it. So this is going to play me the first 5 sounds. Put the integer number box in there. You can shift and drag it to insert it into a patch cord if you want to do that. Just a handy thing to speed things up. And it's going to play sound 1, 2, 3, 4, 5. Very handy. This is actually the first way we've been able to do things in order. And what you're seeing right here is actually, this is exactly what Ardour does. When we put 5 sounds in a row on a timeline, we are essentially doing exactly this. We're playing them in order. And in Max, we just do it with a counter, whereas in Ardour, we do it by laying them in order on the timeline. And if I wanted to play a different sequence of sounds, I could, for instance, use plus 5, and now I'm going to be counting from sound 6 to sound 10. 6, 7, 8, 9, 10. And you say, well, why on earth would you do that when you could just put counter 6 to 10? Well, point well taken. Why do that? 6, 7, 8, 9, 10. Works great. Well, you might discover, and this is one of the treats of sandboxing, making little discoveries. You might discover that the right inlet of plus works the same way as the right inlet of counter. In other words, you can change this starting value of 5 to any other value you put in here. So let's change this back to counter 1 through 5, and we'll start out with a plus 0. What does that mean? That means nothing. Plus 0 means nothing at all. It's going to play our sound 1, 2, 3, 4, 5. But we can change the offset here. So I can put in a 5, and now it's going to play, when I click it, I send the 5 in by clicking the message box. It's going to play sounds 6 through 10. 6, 7, 8, 9, 10. Right? So since the right inlet changes the value, changes the 0 into some other value, now I have a whole other range of possibilities. For instance, I can take a random here. I can put in a random 10. And so now each time this random is triggered, I'm going to get a different offset within my bank of sounds here. So to start out with, I will send this 0 just to make sure I have a plus, I have a 0 in my plus 0. And I get sound 1, 2, 3, 4, 5, get a random number. Now I'm going to have sounds 3 through 7, because this is now a plus 2 object. 3, 4, 5, 6, 7. Now I'm going to have sounds 8 through 12. 8, 9, 10, 11, 12. And if we want to draw the select object back in, I can say, all right, every time my counter gets to the end, every time my counter reaches 5, give me a new random offset. Let me clean up this patch cord. Command Y will clean your patch cord for you so it's not in your way. So I'm going to set this back to 0 just so I know where I'm starting, and set my count. My counter should be at 1, but I can make sure of that by setting my counter back to 1 using the 4th inlet. 1, 2, 3, 4, 5. The 5 triggers the random. Now I have a new range of sounds. Right? Every time the counter goes through its sequence and lands on 5, the select 5 bangs the random and changes the number that's being added here. Now, you might not discover this on your own. That's actually fine. But with actively sandboxing the objects, you can make these kind of discoveries, and that's actually a really powerful one, the fact that the right inlet of plus will change the typed-in argument. And it's a little bit frustrating in Max because this value doesn't visibly change. This will always stay plus 0. Why is that? The reason for that is because when you save your patch and close it, you want to be able to get back to your starting state. So the starting state is always going to be plus 0 when we close the patch and reopen it. It doesn't have to be plus 0. You can put any value you want in here, but just know that any typed in argument is permanent in the sense that you save the patch, you close it, you reopen it, that value will still be there. So unlike something like Ardor, where you want every change to be preserved, in Max you want your starting state to be preserved, and you want the patch to be able to go in multiple directions. All right, so that was counter. Now we'll look at delay. And delay delays a bang by a certain number of milliseconds. And Max thinks in milliseconds, and that can be a little bit frustrating in that you're always having to deal with these big numbers. Instead of saying 1 second, you have to say 1,000. And this is, Max is a piece of software that is originated in the 1980s. It's been around for a long time, and software needs to retain backwards compatibility. And in the early days of computing, floating point numbers with decimal points in them, were harder for the computer to deal with than integers. And so Max was set up in a way that you used a minimum of floating point numbers. So time was displayed in milliseconds, so that you didn't have to say something like 1.5 seconds. You could just say 1,500 milliseconds, and that made it easier on the computer's processor. Of course, we've gone far past that now, and computers don't care anymore whether you're working with a floating point number or an integer number, but the software needs to be backwards compatible over decades. So the millisecond timing has remained in Max, and it's not so bad once you get the hang of it. You end up using this. You end up using times 1,000 a lot, so that you can see seconds even though Max is thinking in milliseconds. And delay is, again, all of these objects are extremely simple objects. This delay line will delay this bang by 2 seconds, then hit this bang. This bang will be delayed by 1 second, then hit this bang. This bang will be delayed by another 1 second, then hit this bang. 1, 2, bang. 1, bang. 1, bang. Okay? And then what we're seeing here is another example of the right inlet being used. So if I want to change this last one to a 5-second delay, I send a 5 into the times 1,000. It becomes a 5,000. And now, even though this internal number didn't change visibly, this last one's a 5-second delay. And we test that out. 1, 2, bang. 1, bang. 1, 2, 3, 4, 5. Bang. I counted my seconds a little fast there. But you get the idea. So again, same thing. We take this into the sandbox and we play around with it. I'll take some structure here that I've got, and I'll say, okay, insert a 2-second delay anytime my random produces a 0. And after that 2-second delay, give me another random value. So 20% of the time, there'll be a 2-second gap in my sound. And there it is. Right? So it random generated a 0, select saw the 0, select bang the delay waited 2 seconds, and then bang the random again. And we can, of course, connect this structure like so. And now 20% of the time, there'll be a 2-second gap in the sound. And there it is. And there it is again. And there it is again. And the reason why that works is there's no sound being played when random produces 0, because the sound that's being played is only played from the reject outlet of the select. And in fact, that would work even if this was connected like this because we're aware that 0 doesn't play a sound. But this is the cleaner, clearer way to do it. And of course, delay has lots of possible applications. If you had, I'll just Option click and drag and duplicate my whole sound file bank there. In order to mix the actual audio together, you can just connect to the same inlet, and this will give you a mix of the two sounds. And what we'll do here is trigger sounds from these two lists with a delay from each other. So I'll get rid of my select and say delay 200 milliseconds. And remember that delay only delays a bang. It does not delay a number. There's a different object for that. That's the pipe object. So we need to convert this number into a bang and delay it. And so when I say convert into a bang, anything you send into a button becomes a bang. The bang destroys information. You send a bang, it bangs. You send a bang a 5, it bangs. You send a bang a 0, it bangs. Anything you send into a button becomes a bang, and delay only delays bangs. So we can have another random here, and we'll give it some offset, plus 12. We'll have the right column play on a delay, and use Command Y to tidy that. And so the first random is triggering a sound from this first bank. We need a +1 there so we don't get a 0. And then we're also getting a bang that's delayed by 200 milliseconds to give us a random sound from a different group of sounds in the second column. Right, so you're hearing that dun-dun, dun-dun, that's 200 milliseconds. That's 2/10 of a second, or 1/5 of a second. And what's a cleaner structure here, again, you're always looking at this as a way to make what you're doing as clear as possible, would actually be this. Because really, both of these things happen at the same time. They're both triggered by the same button. And in fact, we don't even need that button there. So this is a cleaner, more direct version of the same thing. And with a couple of Command Ys, it gets even cleaner and more direct. And if you get in a situation like this where it's a little hard to trace your patch cables, you can always go to the paint bucket up here and just color one of those patch cables. Or color both of them. And now I have a green one and a red one so I can see. And if I want to color the objects, same thing, click the objects and give them a color on their bar so that you can get a cleaner sense of what's going on. I've got my pink side and my green side. And again, we have the right inlet, which we know to be changeable. So we could use the same structure that we used over here, select 0. Whenever the random puts out a 0, we will change the delay time. But here, we're going to need a larger number. Let's say up to a second delay. A random delay up to 1 second. So again, let's walk through this. This button triggers this random. If this random is a 0, You can think of the select object as an if object when used like this. If the random makes a 0, then send a bang out your left outlet, which will generate a random number setting a new delay. And this instance of the bang will be delayed by some number of milliseconds, 200 to start with, but again, after this random hits a 0, it will change that value internally to select the delay between the sounds that are played from the second column. Let's close our G gate and hear what that sounds like. Okay, and these are very simplistic things we're doing as exercises. Of course, if you were going to use this in a creative piece, you'd want to drill down on it further and get exactly the kind of responsiveness you want. And one of the things that Max is used a lot for is to create algorithmic music generators and percussion generators. It's pretty easy to create a kind of artificial intelligence drummer in Max. Obviously, as I said before, not using the playlist object. There's better timing objects that will give you cleaner, more rhythmic timing. But for our purposes right now, this is a very valid way to proceed.